Okay, today we're walking through the definition of proportions, and then we're also going to talk about solving proportions by using the unit rate to do that. So here is our definition of a proportion. A proportion is a statement that two ratios or rates are equal. And an example would be that Sheldon and Leonard are partners in business. Sheldon makes $2 in profit for every $5 that Leonard makes. And there's our first rate that it gives us. If Leonard makes $20 profit on the first item they sell, then you're looking for how much profit does Sheldon make when Leonard makes $20 profit. So this one, the first one, the numbers work out pretty nicely. So let's set up the proportion to start with. So I have Leonard's profit compared to Sheldon's profit. So I'm going to put Sheldon's profit on the top of my rate. And I'm going to put Leonard's profit on the bottom of my rate. And so then as I create these equal rates, it's going to be really important that Sheldon stays on top of the rate and Leonard stays on the bottom of the rate. The rate that was given to me is that Sheldon's profit is $2 for every $5 that Leonard earns. So my first rate is 2 to 5. Then it gives me that Leonard makes a $20 profit. So I need to record that in my new rate right next to Leonard's profit. I want to keep it on the bottom. Then I can solve this just like I do equivalent fractions. If 20 is 4 times bigger than 5, then 2 times 4 is 8. And that means that Sheldon makes $8 profit. And the rate stays the same. These two equivalent rates right here, 2 to 5 is equivalent to 8 to 20. And that's a proportion because a proportion is a statement that shows two rates are equivalent. So let's look at example 2 because example 2 has numbers that don't work out so well. So Allie runs 3 miles in 36 minutes. That's the first rate that's given to me. At this rate, how far could he run in 60 minutes? So we're going to write a proportion. We're going to put miles this time on the bottom and minutes on top. So the rate that's given to me is 36 minutes. He can run 3 miles. Now the rate that I'm looking to solve is for 60 minutes. But what happens is that 36 doesn't go into 60 an equivalent amount of times. But if I simplify this rate, 36 to 3, to find the unit rate, which we've already practiced doing over the last few days. So 3 divided by 3 is 1. 36 divided by 3 is 12. So then the equivalent unit rate would be that there are 12 minutes passed for every 1 mile. Now I can use that unit rate to help me solve for what if 60 minutes have passed. So since I know 12 goes into 60 5 times, then 1 times 5 is 5, and I know that it takes, he can run 5 miles in 60 minutes. So by simplifying to the unit rate, it allows me to find that equivalent rate using multiplication. So let's try example 3 and do the same thing. See if I can get it to show. So example 3 says Mrs. Reynolds' sprinkler system has 9 stations that water all the parts of her front and back lawn. Each station runs for an equal amount of time. If it takes 48 minutes for the first 4 stations of water, how long does it take to water all parts of her lawn? So the rate that's given to me first is that it takes 48 minutes to water 4 stations. But I want to find that equivalent to 9 stations. And since 9 is not a multiple of 4, it would help if I find that unit rate in between. So the unit rate would be how many minutes it takes for 1 station. Since 4 divided by 4 is 1, 48 divided by 4 is 12 minutes. So my unit rate is 12 to 1. That it takes 12 minutes to water 1 station. If I know what 1 station is how many minutes it takes to water one station, then I can multiply that times 9 to find 9 stations. And 12 times 9 is 108 minutes. So it takes 108 minutes to water those 9 stations. And I know that from finding those equivalent rates. And that's